Okay, now we're going to be looking at the quotient rule, which is where you've got things like x squared plus 5 power 3 divided by 4x. So basically we've got two functions, where one is divided by the other. And obviously I can write 1 over v as v to the minus 1. So if I differentiate, I can treat this as a product, two things times together. So let's differentiate u and leave v to the minus 1 alone. And then let's leave u alone and now I need to differentiate v to the minus 1. So I need to use the chain rule for that. Normally I'd write u equal to something, but I've used u already. So let's have w equal to v to the minus 1. And what we want to be able to work out what dw by dx is. So dw by dx is that. And let's put the dv in here. Now if w equals v to the minus 1, dw by dx is minus v to the minus 2. So instead of writing dw by dx, I can write minus v to the minus 2 times dv by dx. So let's put all that back into here. So it's multiplied by minus v to the minus 2 dv by dx. So let's go on to the next slide and simplify this. So this is where we were, so let's write that as du by dx all over v, because that's what v to the minus 1 means, plus u dv by dx, and it's v to the minus 2, so that's v squared, but that now becomes a minus. That minus sign I put there. And v to the minus 2 is 1 over v squared. So let's put everything over v squared. So I've got v du dx minus u dv dx over v squared, and that's what dy by dx is. Sometimes that's written as fx over gx. So I get dy by dx, and the rule is differentiate the top one first and leave the bottom one alone. Then it's a minus sign, and then it's differentiate the bottom one second and leave the top one alone. And it's all over the bottom one squared. So this is a rule for differentiating a quotient. Sometimes it's written with f and g, sometimes it's written with u and v. The bit that goes with this, that isn't on this slide, is y equals u over v. So that goes there. There we go. So either we can have this rule, or this rule is the same one. Basically, if you've got one thing divided by another thing, when you differentiate it, differentiate the top one first, leave the bottom one alone, differentiate the bottom one second, leave the top one alone. Now the order is important because of this minus sign, and if you get this wrong, almost certainly it will be because you've done it in the wrong order. The rule is differentiate the top one first. So you differentiate the top one first. You differentiate the top one first. The u is du, becomes du by dx. That's first. Differentiate the top one first. If I keep saying this, you'll remember. Which one do you differentiate the first? The top one or the bottom one? The top one. The top one first. Let's do an example. So here's the question that we started off with. So dy by dx, I differentiate the top one first and leave the bottom one alone. To differentiate the top one, I've got to differentiate x squared plus 5 cubed. Call this w. So let's write u equal to x squared plus 5. We want to find out what dw by dx is. There's dw, there's dx. Let's put the u in here. So if u equals x squared plus 5, du by dx equals 2x. And we've got w equal to u cubed, so dw by du is 3u squared. So dw by du is 3u squared times du by dx, which is 2x. So that's how you differentiate the top one first. 3 times 2, that's 6x, x squared plus 5 squared. And then leave the bottom one alone. Then differentiate the bottom one second, and leave the top one alone. And it's all over the bottom one squared. That's the answer, but you should really simplify this. I've got x squared plus 5 squared is a factor. And then there's also a 4 there and a 4 there. So that leaves 6x squared, because I've got an x there and an x there. There's a minus sign. The 4 has been taken out, but I've still got an x squared plus 5 left. And then it's all over 16x squared. So that's 4 bracket x squared plus 5 squared. Then 6x squared minus 1x squared is 5x squared. And then it's all over 16x squared.